Hi, it's me, Space Explorer. In the last video I talked about all of the dangers of Mars, so today let's talk about how we can protect the astronaut from radiation. Let's debrief radiation on human health. Radiation can damage the human body in many ways, such as brain and nervous system damage, much higher rate of cancer development, cells being destroyed, and powerful enough radiation can damage our DNA and even break computer electronics. CPUs are most affected by this radiation. It can knock off electrons by triggering the difference between an on and off. Powerful enough radiation can even completely break our electronics by frying them off. Of course, there is redundancy in each spacecraft, multiple computers to double check for errors, but it goes without saying that it could completely break computer electronics. This type of damage is hard to protect against, because we can't see or feel it. In this video, I'll talk about the radiation sources and I'll go over every type of shielding methods that we can use. As always, I hope you guys learned something during each of my videos. After all, I'm doing this for all of you, so please feel free to share your comments and your questions in the comment section down below. Hit that like and hit subscribe button and let's continue. There are three main sources of radiation in space. The first one is from our own planet's magnetic field, which you can see through aurora borealis. The second one is from our own sun, either by solar flares or by coronal mass ejection. And the third one is from cosmic rays, which comes from outer space outside of our solar system. During the Apollo era, astronauts went quickly through the Earth's magnetic field, also known as the Van Allen belt. Our magnetic field protects us from these harmful sources of radiation. In the case of Mars, as we discussed in our previous video, it doesn't have a strong magnetic field. There's one, but it's extremely weak. Generally speaking, our sun is a calm and quiet star. But every 11 years or so, our sun experiences what is known as a solar cycle, which means that the sun's north and south magnetic poles just completely flips over. These solar cycles last for about 27 days on average. During those events, the sun is more active than usual. More eruptions such as solar flare and coronal mass ejection, also known as CME for short, increase during the solar maximum. These eruptions send powerful bursts of highly energetic particles into space. This is really important to shield our spacecraft with everything we have. On Earth, we notice these bursts in the form of auroras or on the impact of radio communication. Extreme eruptions can even affect electricity grid and satellite. During those intense events, a lot of radiation is sent to space, and so the astronauts have to seek shelters as soon as it is detected. Those solar flares are detected by a series of satellites known as GCRs. They collect data corresponding to different temperatures. Computer can learn to find these flares in vast streams of image and help scientists issue timely space weather alerts. That's how we can alert our astronauts to seek shelter before they hit us. Galactic cosmic rays, on the other hand, is way more intense than the sun's radiation. They come from the supernovas that exploded inside our galaxy. We are constantly bombarded by that radiation. They are the most abundant radiation and the most energetic ones. Astronauts will have to shield themselves against those as much as possible. If we're going to go to Mars, we have to be able to shield our spacecraft against those intense sources of radiation. Now that we know the sources, let's talk about how we can protect ourselves against them. Since we'll be spending most of our time in space, either in transit, on the moon, or on Mars, we'll have to make shelters. The astronauts will have to make use of everything in their disposal to protect themselves against radiation. For example, if the Artemis crew is on the way to the moon and they receive a warning of an incoming solar flare, they could use their livestock to hide themselves under as much cargo as possible to help them during solar flares inside the Orion spacecraft. The more mass between the crew and the radiation, the more likely that dangerous particles will deposit their energy before reaching the crew. Teams across NASA are coming up with creative solutions such as wearable vests, device that adds mass to your body, or electrically charged surface to deflect radiation. But these types of protection are mostly good against minor radiations. Cosmic rays, on the other hand, can pass through aluminum but can be stopped using thick materials such as concrete, multiple layers of metal, water, or even a combination of those. Consequently, a great deal of research has been performed on a lightweight polyethylene plastic called RFX1, which is composed entirely of lightweight carbon and hydrogen atoms. Research shows that polyethylene is 50% better at shielding solar flare and is 15% better at shielding galactic cosmic rays as compared to aluminum. Water is another hydrogen-rich molecule that can absorb radiation. However, the oxygen content in water makes it a lot heavier than the polyethylene and therefore is much more expensive to launch. Generally, lighter shield can greatly reduce the harmful effect of incoming space radiation particles, but they cannot completely stop them. There is also the development of electrostatic radiation shield, which generate positive and negative electric charge that deflects incoming electrically charged radiation. This method, however, requires a lot of electricity, and we currently don't have the means to do that, but it would create a protective barrier around the ship. The same way that the Earth's magnetic field protects us from the sun's radiation, we could use that same technique to protect our spacecraft using electrostatic radiation shielding. Electrostatic shielding has proven to block almost all of the sun's solar radiation and block cosmic rays at over 75% more effective than aluminum shielding. This is the best method of shielding that we have right now. Imagine combining electrostatic shielding with other materials and techniques. We could be blocking radiation almost entirely, making any interplanetary mission much more feasible. Another way that we can shield ourselves is the use of regolith available on any planet such as the Moon or Mars. We could dig the regolith and cover our habitation module with it. It does not cost anything and you don't have to bring it before the launch, and it does provide some protection. If it becomes viable, the best method would be to simply build our bases underground, either in tunnels or caves, as it would provide an almost 100% protection against all forms of radiation. But if you choose to live under surface and you have enough power protection, you could use the electrostatic shielding on the surface of any moon or planet. The last radiation countermeasure that we have is a dietary countermeasures, which is a drug that when ingested by an astronaut have the potential to reduce the effect of ionizing radiation. These supplements can be broadly categorized into two groups. The first group includes specific nutrients that prevent the radiation damage. For example, antioxidants like vitamin C and A may help by soaking up radiation-produced free radicals before they can do any harm. Research also suggested that pectin, fiber from fruits and vegetables, and omega-3 rich fish oils may be beneficial countermeasures to damage for long-term radiation exposure. Other studies have shown that diet rich in strawberries, blueberries, kale, and spinach prevent neurological damage due to the radiation. In addition, drugs such as radiogardas are designed to increase the rate at which radioactive substances like cesium-137 or thallium are eliminated from the body. The second group of dietary agents currently being considered for protection against ionizing radiation includes drugs that can facilitate faster recovery from radiation damage. Although these types of drugs, called radioprotectant, are now used to treat people to radiation contamination on Earth, they may be good candidates for long-duration space mission. It is important to note, however, that when administered in effective concentration, some radioprotectants also have limiting negative side effects such as nausea, hypertension, weakness, and fatigue. In conclusion, we have a few options for protection against radiation, but the best of them all is the electrostatic shielding, as this can be used either in space or even on the surface of planets or moons. They offer the highest protection amongst all of the choices that we have. We just have to find the means to generate enough electricity to use it as soon as possible. Alright, that's it for today. Hit that like button, the subscribe, and leave your comments down below. Over the next week, I'll be posting my recap of all the important rocket launches of 2020. Meanwhile, keep exploring space and stay curious. Happy New Year, everybody. Peace.